All right, welcome. It is Wednesday, December 21st. It is almost Christmas time. Happy holidays, everybody. This is the last broadcast of 2022 for the Digital Roundtable, and we have a great guest. The youth is in the house, changing the world one day at a time. But before we get rolling, let's have some music from our own Dr. John Sibley.
Chestnuts roasting on an open fire, and Jack Frost nipping at your nose. Yuletide carols being sung by a choir, and folks dressed up like Eskimos. Everybody knows a turkey and some mistletoe will help to make the season bright. And tiny tots with their eyes all aglow will find it hard to sleep tonight. They know that Santa is on his way. There's a lot of toys and goodies on that sleigh, and every mother's child is going to spy to see if reindeer really know how to fly. And so I'm offering this very simple song to kids from 1 to 92. Although it's been said many times, many ways, Merry Christmas, Merry Christmas, and a Merry, Merry Christmas to you.
Very good, very good.
I thought I would do the whole thing. How are you doing, Andres?
John Butler, how are you, sir?
I am doing fine. There's a lot going on. Been talking over to a lot of lawyers about what's going on in Washington, D.C. with the president, and whether or not the committee, has we're going to go through a whole lot of stuff in America that could have a lot of emphasis on national security. And is this a grand jury that's recommending it, or is this a something from Congress, that's recommending it? And the question is, what's the ramification for American security? What's been hidden and those kind of things? Otherwise, it's gotten cold here, but it's pretty nice. I went out and hit some golf balls. It's a little chilly for a Southern boy, but I hit some golf balls, and I'm waiting for the 12-degree weather that's going to come here, from Texas. I've been working with distributive occupations where people work in the future. And that's really, really pretty wild, because as we look at the prosperity of America now, we have two things going on. On the one hand, we're global, and on the other hand, people need jobs in America. So if we go with a distributive workplace, nobody wants to go back to work, nobody. Then why can't I just hire an engineer, or why can't I just hire somebody from overseas and don't worry about our workplace here? We have a new mayor in Austin, Texas, a good friend of mine, and I'm sure that Austin will move forward as we always have. It's been an interesting thing now that's happening in Europe, and my understanding is that the Soviets thought they could take the place in one day. Obviously, that did not happen. So as a result of that blunder, we are facing a wintertime with lots of energy kinds of demands from that part of the world. I expect a big exodus from that part of the world to America. And then we have the border in Texas. We have the border crossing in Texas, and it's been there a long time, but these are not necessarily from Mexico. They're from all over South America. And I've been working with some people to create entrepreneur activities or entrepreneur firms for a lot of the immigrants that will come to America. So it's been a busy time. And other than that, with the exception of my coach got, suspended at the University of Texas, Christmas will be fine.
Good deal, good deal. Llewellyn King, how are you, sir?
I'm mostly all right. I'm taking a cough lozenge because I have a continuing virus, which seems to become almost a permanent part of me, very disagreeable, but that's so that I don't splutter to the cough lozenge, so I don't splutter on the computer. Otherwise, all is well, or as well as can be expected, given the vagaries of the human condition and the state of the world. John is quite right. The situation in Europe is atrocious. They're going to have, as we mentioned on this program, week after week, a terrible winter. Energy is number one issue. There isn't enough of it. And Putin's number one weapon in his war of aggression against Ukraine is the cold and the dark. And he is attacking electric supply, and that is a harbinger of the nature of war to come. You see the outlines of future warfare when you look at what is happening in Ukraine, which is the extensive use of drones, unmanned vehicles, and the primary targets are no longer industrial production, it is electricity, because if you knock out the electric system, these must not only do you punish the civilian population, but you knock out industrial production, war production, etc. And very quickly, you bring a country to its knees and worse.
Yeah, absolutely. So we have a great guest today, and I'll get to introduce him in a moment. I met him a while back, and we had him at the startup showcase at Digital Roundtable, and he leads a pretty exciting company. Ethan Duran, how are you, sir?
Doing well. How are you doing?
Good. Thanks for being with us.
Yeah, I appreciate the invitation.
Absolutely. For those of you listening and watching that don't know about Ethan, Ethan is actually a very young man, as we would all would say. He is a superstar, a brain, a product of great schooling and determination. He will be with us for an hour to talk about creative 3D technologies. He actually got his way into his current role from being the owner of EV3D. And before that, he was a 3D printer technician at Tapster Robotics for a few months, where he discovered this passion of his in this new market that he is actually innovating on and transforming. Ethan is, had the fortune of being too smart to go to college. He's a self-made polymath. And in high school, he was a superstar. He went to Fenwick High School, where he was part of the debate team, where he competed internationally at Harvard. He was in the robotics team as a leader as well. He was in the wrestling team. He was in the esports team. He was in the investment club. And the guy there's no challenge that Ethan has not gone after and conquered, including 3D printing parts of his own car that he drives. And he'll tell you more about it. But Ethan, welcome.
Thank you. You got the whole history.
So Ethan, tell us real quick about creative 3D technologies. What are you doing? What's your vision? You're changing the world. Tell us about it.
Sure. Yeah, I'll try to give the shorter summary, because I think it's tough for a lot of folks to really understand why we exist in the first place, or why this technology is here, without understanding the market that helped prompt it to come into existence. I think a lot of people look at 3D printing and say, oh, there's so many companies in it, they're all doing these different things, and there's such tight competition, and it's really not the case. I think 3D printing has been progressing exactly how paper printing has in the past, where in the past, if you want something paper printed, you wouldn't have a paper printer, you would send that job to a print shop. And that print shop had all the specialty tools under one roof to make it happen. You want something like business card size, they have one tool to make that happen. You want prints more on the newspaper size, that's a different tool. You want to manage the different pigments, different textures that are going on these things. You want different fonts, and different fonts are equipped in each and every tool, and you need a whole lot of them to make your final product or a variety of different products. And there are very literal print shops today for 3D printing. You want steel, great. You buy one high-end, very expensive industrial machine that needs all these little side modules, and that's all it'll do. It'll only print steel. If you ask them, can it print titanium? They'll ask you the salesman question of, why do you want to print titanium? They won't tell you yes, and they'll ask you why, because that's someone else's submarket. And if you want either of those machines to probably do something more intense like an Inconel, you're now jumping up another tier. You want any of those to do your standard plastics, different type of printer. You want, say, your standard plastic printer to do something with like fingerprint levels of resolution. You want a plastic part that's the size of furniture, like a bar stool. You want any of those to do like carbon fibers. You want Kevlars, you want medical grade, you want really fast parts, you want smart systems introduced into your 3D printing experience, so you can start to distribute your factory and production needs, and all the different things you could want need all these different tools. And that's why print shops exist, because with 3D printing, you have all the printers under one roof to make that happen, from your metals, your plastics, to your fine detail, to your furniture size. They have them all. So my company started is because I didn't like that. So my last business was I provided a lot of the refurbishment, but also R&D that helped put and define a lot of the larger 3D printer manufacturers in the market right now, because they bought IP from us to develop and innovate on their printers. And you get a lot of information for doing that from a long time, and you know a lot of market dynamics. And I was just frustrated with needing an entire suite and room of printers just to make a basic variety of parts. And God forbid you want a part that needed multiple printers. Like we were doing large electronics cases. Best way to do is large, less precise printer. You don't have the precision to really fit in your electronics and make it all come together, because that's a more detailed printer's job. So you manage all these printers, glue them together, and hope the God your stuff works. And we started because, similar to how Xerox put the whole print shop into one machine, and now there's a paper printer in just about every office, we're that similar all-in-one shift for 3D printing, except we actually function and work reliably. So doing an entire suite of 13 plus separate specialty machines would typically do all on their own in one platform that has the speed, the tolerance, the precision to do all them, while being more than 95% less expensive than the closest competitor. So trying to make it accessible to a lot of people that can really benefit from that tech.
Right. And hold on, Johnny. And Ethan, today you make these machines, and I've been to your shop, which is pretty fascinating place. And your machine is kind of the size of a desk, kind of volume wise, even though, it's kind of like a shell, looks like a baby crib. You inside it, and you print the object inside and kind of thing, or on top, right? And who buys your stuff today? Is it me that wants to start a printing thing, or is it the Air Force? Is it the Department of Defense?
Sure.
Who's buying this stuff?
It really depends on what needs to be made. I am 3D printing, and I think the main reason why it's not been popularized and everywhere has been it's not efficient enough, and it hasn't been able to make good enough of a quality final product. It's more been a way to make a model that could represent a final product and help someone go from designing to visualization in their hands quicker. But it hasn't been final product quality. It hasn't been something that you could print out and trust to have in your car, for example. And having that be final product quality, bringing the machine's tolerance, its resolution, and its strength to that point needs to be a massive step for the industry, and that's one that we're taking. But on top of that, we're making it more efficient for production, because you can, what we like to show a lot of folks is 3D printing is typically a jobbing method. Say you have a big area and you can fit 50 of these little pens on there, just because I have it on my desk. You can fit 50 of them on there. If you want to print 50 sequentially, one after another, of just one on the plate and print one after another, or if you can fit all 50 on that plate and print them at the same time, because you only have one printing head working on 50 parts, it's going to take you the same amount of time to make that piece, no matter if you're doing it sequentially or all at once. So by improving the process, by making it a batch process, making multiple of those parts at once, making a sequential batch, and Autos to be able to finish your parts and start new ones is when it starts to become more financially efficient, you start scaling that around too. So if you have a final product and it's efficient to make that final product, then that becomes relevant to a lot more people. There's quite a few customers because I've always wanted to have this be relevant to as many people as possible to help them innovate. I love the idea of empowering people's ability to create without a lot of the constraints associated with trying to do so typically. So if we can take away what engineering schools teach you, which is not what to make, it teaches you how to make it. These are what shapes you can and can't manufacture. This is how you document yourself doing so. This is the process. And here's how you can make your final product. If we're making a method that starts to challenge that in a lot of ways, and you enable people to really have access to that technology instead of saying, oh yeah, and you can do this, but that machine's going to cost $1.2 million. And I like seeing what people do with it and how they can keep pushing those barriers. So we'll get anyone from your small startups where instead of exporting off to China, they have a free trial of a CAD software, they keep designing and then they just throw it to the printer and they have something with the strengths and tolerance and close to a final fish what you expect, and then they can go and just keep iterate print until you have your final product. Or what a lot of people do is they buy a machine, they load up version 1 through 10 on the plate, they click print, the next morning they have them on, then they can test them and see which one works. And that's cheaper than designing. And well, a lot of times after you design, you have to virtually simulate it. You hope you test what it's like in market. That design, those simulation softwares cost a lot, and then you pay China to tool up, and then you hope that God that works. And if it doesn't, you have to pay it all over again. Having a machine to do that, to go from design to product to iterations to final product, and then get it into people's hands at light scale, really helps. So we'll see the startups, we'll see the large world militaries, we'll see your Fortune 500s, your automakers, and everyone in between in that range too, from small and medium businesses, research labs, universities, machine shops, print farms, and we get a little bit of everyone. We even have a Michelin star kitchen that's looking at getting one so they can print these cool chocolate structures and fill it in with whatever like cream paste that they're making on the inside too. And if there's a physical product, it's been interesting to see what people find application for.
These guys are ready to jump in. Johnny, go ahead.
Well, Ethan, I think you're selling yourself short. Now, I'm not going to charge you a consulting fee for my comments, but if I remember when the goat bought or somebody created his liquid model recorder to move mail around, our vision with that, we would not have to carry anything to the moon. We would 3D print it on the moon. Mm-hmm. So we don't have to take any kinds of materials to the moon. We would just, NASA would say we would use 3D printing. So I think that the technology really came out of NASA, and they did some of the very, very creative stuff. I guess my question, and I've had just tons of students over the years to present, 3D models, everything from when I buy a rake in the store, I can print it out at home rather than bringing it home. But my question is this: I think your challenges, and correct me if wrong, first your challenges and then your advantages, is that the material forms, right, have had to change so that they could enter the 3D printing market, right? The model, right? That is, it'll be difficult to take some materials, and I think it started out as those materials that were very, very foldable, if you will, to do what you need to do. The advantage is you can model things and create things that no human hand or human mind or even could ever think of manufacturing. So the question is, are you looking forward to the NASA tradition? Are you having interaction at all with NASA? And the second one is, what's your interaction with doing products rather than doing models, when the nature of the materials would change? We can do a house now, but I don't know we can do a car because of the nature of the materials. Okay, that's my two questions.
Yeah, so
I'm not charging any kind of tuition.
Yeah, so first is on the space side of things. We have actually talked to quite a few space companies because our method of 3D printing doesn't need gravity. There's a couple methods of 3D printing. And the first one that really ever started back in the 80s was called, well, there's SLS and SLA, which means selective laser sintering, or they're both basically processes that have some material plus a laser. And with SLS, it's a big vat of powder that laser is melting the powder essentially. Or there's SLA, which is a vat of resin with a UV laser curing that. And well, you do have to get really materially specific on both of those because you have to deal with your materials and, oh, well, how do we bind them together? How much, and you're really doing a lot of chemical engineering, especially on the resin side for it, if you're doing that resin method, and that has been tougher. But there's also the third method of FDM or FFF, which means fused deposition modeling or fused filament fabrication, which is taking material, melting it, and just pushing it out. And in my opinion, that's the best method because if you have a big block of powder, if you have liquid, you throw that in the space, that's going to be everywhere. It's going to be floating around versus if you're working with adhesives and building something off of that, it doesn't matter if it's on its side, it doesn't matter if the thing's upside down, it doesn't matter if it's shaking. And if you have a well-built machine, you don't need that gravity element. You can continue to lay down and build up. And that's the method that we've built off of, but taken to an extremity. So even though we are an extrusion-based system where we're pushing out material, we're able to do so with better precision than the laser machines and doing so in more metals and other materials that a lot of folks typically wouldn't be able to support in one platform. And so bring what would typically be, by some estimations, a couple $1 million of machinery into one platform opens up a lot of opportunity for a lot of people. But for us, it opens up a lot of potential because if you have overkill in terms of how hot you need to get the thing and how precisely you can push out material, and you really work with these material manufacturers, you can build a machine that best suits them. So you're not having them adapt materials for your method, you're building your method around what can and can't already be printed and easily processed. That's why we're able to work with raw ocean plastic. That's why we're able to print out of like algae-based materials. That's why we're able to print out a material that would be typically scrap metal or even waste metals. Like we've been talking to a lot of folks on the jewelry side. If you're making jewelry, there's a lot of wasted shavings and powdered golds and stuff that no one knows what to do with. And oh, great, that's the perfect input for us to actually print with them and take something that would have been a scrap product and turn it into something that can really benefit you without having all the extra steps and added waste to it. So my answer to materials from changing it from just models to final products is I have really been on that shift. I have been helping push that and usher that through with my company. That's why I'm able to make final products. And I printed the control arms on my car out of 17-4 steel and printed out, sintered it, did a basic powder coat on it, and I designed it up so I can turn my wheels almost 80 degrees and drift the thing. And I've beaten it up for over 12,000 miles and it's been fine. That would be tough to find another printer that could really do that, especially if you're anywhere near the price point. So I can confidently say we've hit the final product threshold.
Well, Ethan, the issue of 3D printing came to the great state of Texas when we had a law student who started printing out weapons or guns.
Yeah, Cody Wilson, he's in Austin, actually.
And in Austin right here, and his issue was, it's a free country. I have a printer, and I should be able to print out anything that I want to print out. So he started printing out weapons. And these weapons would shoot, they would hold bullets. So my question is, this is a very, very disruptive technology in the long run. It's disruptive in terms of the workforce. So who needs anybody in manufacturing when you print out everything? And Llewellyn does not believe this, but he'll go buy a car and he will print it out at home in the future. So my question is, when it comes to the legal apparatus of the things that you can print out, it's not like somebody can make a soap gun or somebody can make a gun out of wood. This is a gun that shoots, and it came to everybody's attention about 10 years ago and threw 3D printing into the limelight. There were lots of discussions, and the issue was, what are the legal ramifications? Can you make anything you want to make through 3D printing? How do you view this case, Ethan? going forward in putting 3D printing in the hands of anyone. So I could print out a weapon. I could actually print out an automobile myself. We have 3D printing houses in Austin, Texas. That's just fabulous, by the way. How do you see the legal ramifications?
I think it's something that needs to be reevaluated in terms of regulation on it, because what was so interesting about Cody's case with all the 3D printed guns wasn't so much what was being made, but how he crafted. I give kudos to his just legal understanding of how he crafted, because if the government tells you, oh, well, you can't just use and share these 3D models, then that applies to any digital file you share. That means that government can have regulation over that. That was so interesting why that case went all the way up to the Supreme Court. From the machinery perspective, you are, especially with what we're doing, you're giving the general population, if they buy such a machine, a lot of potential. And that does get complicated. And if we're talking about, but we're still selling a tool. Say you go and you want to buy a hammer. You can use that hammer to hammer in nails, but you can also use that hammer to hurt someone if you wanted to. The hammer company's not telling you exactly how you use, and you have to use your hammer for this and this and this. It's a tool that can be used how you want. And just like a hammer, we're providing a tool that can be used how you want. You buy a paper printer, they're not telling you, oh, you can't print this document, but you can print these documents. You just have a printer and you have a method to do so. Going back to 3D printing, if you print that gun, that is your responsibility that you're printing. If you do make a full ghost gun, I mean, that's your responsibility if you just made that. That's not the responsibility of the machine. It's just a tool. You're the one that did it. So that's where I think a lot of the legalities start to fall on people, but I do try to take a bit more responsibility with it. And we're starting to evolve our offering in terms of the machine. So we're moving a little more closer to 2026 on the final product side. So making essentially an end-to-end product, including wiring, circuitry, motors, and everything built into one, paint, finishings, polishings, things like that. And being able to Star Trek replicator style make a lot of final products out of one machine, and be doing so in a competitive price point to centralized manufacturing like China. And when we usher that out, which is why we're taking a while to do so, we want to also be able to help people on the IP side of a lot of models, because it's model sharing that causes some of the problems. So what I'd like to do when ushering that in is, because it's a method that can conveniently make custom products, a product that's tailored towards your use case, your size, your application, your needs. And if you can make that, again, competitively priced with centralized manufacturing, we can build a custom marketplace for products. So wherever there's one of these machines, say it's your off hours, we can read, okay, what materials are in it? What products can you make with this? Cross compare, okay, here's all the products that we go out, we partner with, and we vet as a good product. So if we don't want to associate with guns, we want to associate saying you can't buy that gun. That would limit someone from having that printed there. But if we start to implement a lot of new techs in doing so, like blockchain, for example, we can see when files that have been uploaded into that market or that someone's used or interacted with, we can see when it's been printed and vet, like, okay, this is something this is final product quality, this is a vetted piece, instead of just having a model of it or something that's a little less trackable. So adding a bit of that element not only helps the authors or whoever makes these new wave of products that are all going to be digital, but it also helps, keep everything a little more regulated and keep track on if someone wants to do something like that.
Llewellyn.
I've followed 3D printing, additive manufacturing for some time, and was very excited about it initially. And I've seen it in use. I've seen a compressor manufacturing facility in California where it is part of the production line. There's here in Rhode Island, where I am, there's a bakery supply company that uses off-the-shelf printers to print the items they sell. So there's been a fair penetration of the market, although not as dramatically as we've been led to believe. At one point, I think the Dutch said they had printed a house. Listening to you it seems to me the challenge is in the feedstock, not in the printing side of it. And then we thought there was going to be a huge burst of activity when sintering became off patent somewhere and was more generally available, if I got that correct. Isn't this something that is evolving slowly? And does it really need what you've laid out for us, which is a one-size-fits-all machine? Maybe it doesn't need that. You know, we have in manufacturing plants, we have shaping machines, we have lathes, drills, but they don't all come in one package, and nobody's ever thought that it was desirable that they should. Are you, that a fair criticism of the possibility of you're trying to offer too much in one product?
Sure. Okay. So I know there's a couple of questions there. I got the last one of, is all-in-one necessary? What was the one right before that? Just so I can hit them in order as well. Was it more on, was it the evolution of the machines? If it's the material, that's the issue, not the printer. Okay. So I think it is a little more on the machinery side, at least if we look at how the industry has evolved. There have been a few designs of printers that caught a lot of traction initially and done really well. And instead of evolving upon that, instead of making new designs, a lot of the industry has just done incremental changes, added a little new feature, made something a little like 10% faster, not redesigned and rebuilt the whole thing from scratch. And that's the approach that we took. I'm not basing our design on any of these principles, but reteaching these machinery shops to, okay, no, this is how you should be making these parts for us, because this is how much different it is from, say, a CNC in terms of how it moves, in terms of design, a lot of other areas, and retrain a lot of folks to make a machine that can be better. That aspect was hard. And that is a challenge if anyone wants to continue to push on the machinery side. And feedstock wise, and we support more materials than just about anyone out there. If it melts under 500 degrees centigrade, if it comes in a paste, it can be heated or chilled and pushed out in some way, we can support it. Or if it can be ground down from pellets, we're there. And not many people can say that. So I think material wise, it's been growing at an astronomical rate. And in terms of the industry, how it's been growing, I think that's something that a lot of people haven't quite understood. It's right when the patents dropped, right when sintering and things like that became public and more people really flood the industry closer to 2012, everyone was thinking, oh, this is that Star Trek replicator. It's going to be in everyone's house. It's going to be that ideal consumer product. And that's just not the case. That's not how 3D printing works. And that's not the impact it's meant to have on the market. And after the big media buzz faded around that, no one's ever really heard about it. But if we look at the market, it's a $22 billion marketplace that's growing at a 30.2% CAGR. And if that's not massive, rapid growth, then I don't know what is. It's been making massive impacts and waves, not in the public sector, because I don't think it's an everyday consumer product. Let's look at how paper printers are used. There's a paper printer in a lot of houses because everyone has a skill set to use them. They're literate, they can go to a computer, they can open up Word, PowerPoint, they can translate the idea they have in their head, they have the skill to make it, and then click print. And until 3D modeling's like that, where they can think of something, design out and click print, or they can just go to a repository and find it, then the only consumers are the people that are going to be the people that can go to a repository and find it. And that's why you've got the hobbyists and the engineers buying them, but not your everyday Joe, because they can't imagine something and print that final product out. And that skill set's too far away. So it won't be a consumer product, but it's made massive waves on the industrial end, because just looking at prototyping, which is about 40% of the use case of the industry, it's really shifted things. Like I said, it's gone from design, pay crazy amounts of money to simulate, pay a ton of money to tool up and then make that product and hope it works, or it's changed that to making now products representative in terms of tolerance and strength of what you actually want, and giving you that product earlier and taking it from concept, design, iterate till final product, then get it into people's hands. And that pivot has been massive. It's made people a lot of money. It's saved a lot of money. It's empowered people to make new products and start to challenge what we can do innovation wise. And that's why we've been seeing the benefits of that across many industries. So it's not a consumer product. I think it's going to be a very long time until it is. But in the meantime, it has certainly been a large industrial wave and something that's empowered a lot of that productivity, creativity. And if you can have an excellent machine that can do so without constraints, might as well. But the last question I even asked was about why do an all-in-one? Wouldn't the dedicated tool be better? If you're in the wilderness and you need a knife, you'd rather have a proper knife than just the knife end of a Swiss Army knife. Even though we're a multi-tool and you kind of think it'd be jack of all trades, master of none, well, the full phrase of that is a jack of all trades, maybe a master of none, but still better than a master of one. That all-in-one tool that we've made is a bit of a master of all trades, because we didn't build it. We weren't aiming to build an all-in-one printer. That wasn't the aim from the beginning. We just want to build something that worked and worked well. And because I've been personally in well over 100 different printers, I know why they work. I know where they fail. I know what features they can and can't do. I know why their company started and why they failed. We were able to take all those insights and translate into something. Every single part in our machines are designed to eliminate another problem that people have with 3D printing, enable another function, enable another feature to make the whole process better. And when we built that, we realized, oh, well, should we make this a detail printer? We built the platform. It has single micron tolerance. Should we make a detail printer? Well, no, because this same platform is capable enough to do something furniture size. So maybe we should do a large printer. Well, we have the speed to be a high speed printer, so maybe we should just do that. It didn't make sense to focus in one. So I can go down a list of all of the 13 different printing functions I mentioned, how we're individually better. You want metal printing, for example? Great. We're 99.99% less expensive than just the printer that only does one single function is printing metal. So machine cost, there's already a massive discrepancy. We can print that metal for 30% less cost per gram. Usually when you're doing sintering, when you're doing metal binder jetting, you have half bound or half melted material in a vat of powder. And at best, 50% of that tends to be waste powder. So if you've got, say you've got my phone area that you can build something on, this is all you're building and this is all waste area around it, then a lot of that material, about 50% of it would be scrapped. It would be gone. Even though you only printed that cube, the rest of it is still excess scrap material. We only print what we use. So we're top that 50% less wasteful at the high end. On top of that, we can print your metal part in shapes and geometries that no one else can, because if you want to do, say you have a hollow part and you build like an internal structure within it, if you were to top that off with binder jetting or sintering, you would have unsintered or unbound powder in the middle. It'd just be loose. But we can, because we're not depositing powder, we can lay that down. We can do those complex internal structures, and we can even mix multiple metals. Only because we're a multi-suite machine, we can mix multiple printing formats or different metals into the same part. So if you want a steel part with Inconel reinforcements, as long as those sintering coefficients are pretty much the same, you can mix them in the same piece. If you want something the size of a chair for the outer precision of a coin face, another impossibility in 3D printing, but we can mix the detail in the large format 3D printing in the same part and build these different pieces. So in just that one function, our metal printer, just as a metal printer, and you don't care about 12 other types of printing, is better than anything that's out there. You want just large plastic parts? Great. We'll be 80% less expensive than the closest thing to us that can just do that size of part. We'll print that part 90% faster. We can do finer tolerances, finer finishes, make something that's better, and then outperform them in just, again, that one function. Each individual thing, this can be a very long list, but even though we're a jack of all trades, we built this to be better than any of them. And we built it to be a modular platform that exceeds anyone that's out there in terms of speed, quality, precision. So then as printing evolves, even 5 years down the line, swap on the latest tech. Then you come back to us, swap on the latest tech, and then you're ready to go with something that would typically take a completely different printer. So
Ethan,
usually the multi-tool makes sense.
So
But
Ethan, Andre, let me just jump on
Sure.
my young colleague here. Ethan, you're talking to a demographic age that saw when people said, oh, computers would never be utilized only for big organization, they'll be the size of a
Sure.
room. You're talking to a demographic who saw IBM give the software to Microsoft because they said, oh, it'll never be on a desktop. And now we have it here. So my question, and then of course, when you look at if we go across the years, computers actually make their money off of the paper and the ink rather than the computer themselves. So looking forward, I think two things will happen, and this is just a comment here of the old professor. I think that 3D printing will get smaller. I think it will be used by commercial people. I think toys will be printed out at home. And I also think that you will make your money in the future, not necessarily on the printing, but the materials that are utilized to go into the printer. So don't sell yourself short on the historical significance of what you're doing. The fact that 3D printing would have a big impact on the industrial section, but it'll also have a big impact on office. I mean, I can just sit there and print out my ink pen. I can sit there and print out my my paper clips. I might even be able to sit there and print out a computer. So as we look into the future and look into the past, all of the technology, including the airplane, one of Lou Allen's great technologies he'd like to talk about. When the Wright brothers took out, I could not even imagine. There are two things I cannot imagine: television and flight, right? So, don't sell yourself short in terms of the future of the importance of this technology. So why should we fly? I mean, why should we fly things around anymore? Just print them out in the location and go from there. So that's just a comment from the old professor. So you get my age, you're going to say, you had this crazy guy who was telling me how great things were going to be. So go ahead. I know we want to not run.
Yeah, I actually want Ethan, who doesn't lack vision, and he is actually a phenomenal human being.
Is that an hypothesis? Sounds like an hypothesis to me.
Hold on. So I want Ethan to share his vision of the next version of the machine, because he told me something a while back that I found fascinating. He wants, with artificial intelligence, make machines that make things.
Yes.
So where are you on that, Ethan?
So that gets kind of to what Johnny, you were mentioning about being able to print the whole car, that kind of deal.
Yeah.
I'm still not sure if that'd be an everyday consumer technology, but I'm sure going to try and make it. So we're pushing later towards 2026 to be, well, take a step back. I definitely think a lot quicker than I speak. Similar to how we took 3D printing and took the approach of doing one entire room full of separate 3D printers that need to do and put it into one and build a platform that can do it. We were thinking, well, what if we evolve upon that? What if we build our platform, but with zero compromise, absolute best, all the wildest technologies no one even thought or figured out that could actually be implemented into 3D printing, build it all into it and see how good we can make this. And in terms of precision, speed, encoded tolerance, and modularity, we built a platform that can not only autonomously swap in all the methods I mentioned, your plastics, your metals, your continuous strand carbon fibers, your different paste materials, and build them all into the same part, but then start to swap into other manufacturing methods that no one's really thought of making additive. No one's ever thought of making this method a layer by layer process. So as you're building up your 3D printed part, we started approaching like, oh, well, what's wrong with 3D printing? Prints have layers. Well, what if we grab in a multi-axial milling module that can grab that, and as every few layers you build up, start to smooth it, make it look like an injection molded piece. Great. Well, what else is wrong? 3D prints tend to be monochromatic. What if we grab an inkjet head to fully color the piece as we're making it? What if we grab in pick and place? So instead of needing to assemble your piece after you've printed a part, load up your motors, load up your electronic boards, load up your screws, inserts, whatever you want to put in the thing, all your little add-ons that will take your assembly step, load them into a machine, and as you're building it up, build it into the piece. Like we started doing a couple really interesting pieces that instead of needing to actually drop in like our electronic board that had a hole right there that we'd put an insert in, the machine grabbed that insert and heated it up and built it into the piece. And then we dropped in the electronic board and screwed it into place. And then the machine itself, as we started building around that and drop the board and start building it into the part itself, we identify the pins on the thing, we wire it, in between the layers themselves is silver ink. So that's now wiring that electronic board to motors and everything else that you want to put in it. And I'm starting to build and turn this into a final product while also making that product qualified, because that's the biggest issue in 3D printing. It's not been consistent enough to have a qualified final part. You're on a battlefield, you're sending something into space, you need parts that are built to aerospace or military spec. And if we approach this from a data aspect, build a machine that can take in more data than anyone else. We see how fast things are supposed to move versus how fast they actually move, how much material is requested to be output versus how much was actually output, how much that material differentiates. So if someone tells us, yeah, our wire's 1.75 millimeters thick, well, it might be 1.8 in one area and 1.7 in another area. We'll actively measuring that and compensating for that in the process. And also implementing things like machine learning to cross compare each layer as you're building it up to your CAD model. Simple algorithm, put them side by side. You can set a margin of error saying, okay, if it's 99% within this size, then this is a qualified part. And if the right amount of material is deposited and it fits within that size, now we just built in all these different manufacturing methods into your same piece. We took out your assembly line. We took out all these different separate cells on your production line and the shipment, because we have this machine right where you need it. It builds your final product and it's a qualified part you can put anywhere. And then if we make that, so then we start supporting different products, like this kind of doing custom in your headphones. And we taught them saying, hey, your thing's pretty expensive to manufacture right now, because their model is take a photo of your ear, send it to them, and then they build one built around your ear because it's supposed to be safer. You go saying, hey, your machine's manufactured, here's all the modules that can do it, work with us because we can cut out middlemen like Amazon, and we can give you better than a factory direct pricing, because say that headphone takes 15 manufacturing cells to make, and each of those cells can cost anywhere between a couple $100,000 to a couple million, then we compress that in instead of having now the factory compensate for that machine cost and the product cost, compensate for the labor and the product cost, the shipment, the distribution, the fuel, the waste, and all, and you do it in one machine. That's when you be competitive with centralized manufacturing, and you put that anywhere. That's how we can offer brands an even more competitive price. And then you as a customer, you can take your ear pick, you can upload it, you can buy it from us, and that will be sent to the close machine to you. And then you can basically pick up those headphones in less than an hour.
Ethan, what is your ideal customer and what is your customer manufacturing?
For that machine or the 3D printer? So we do have to differentiate them differently. The 3D printer, and we just call it the 3D printer, but the other one, because it involves 3D printing, but it's not necessarily 3D printing alone. We've been told that we have to give it a name. So we get to name a type branch of technology, which is exciting. So and we're calling it 3D fabrication. You 3D print a part, you fabricate a product or assembly.
Well, your second, your complex, your Swiss Army printer.
Okay, so the printer, the ideal customer that we see for the printer is probably, I define it as the middle market in 3D printing. Function is a false divider for the market, but the real dividers in the market are price. How much can you afford to buy a printer? There's a sub $6,000 consumer. It's not an everyday consumer, but your engineers, your hobbyists, maybe your smaller startups would fall into that. There's a sub $50,000 middle market of small and medium business, your research labs, your universities, print farms.
Can you give me
a lot of folks on there?
Please, I'm trying to get some answers. Give me an ideal company and why they would buy this printer and what they would do with it.
Well, I'm not going to tell you, I want this kind of person that's going to nail, say we compare this back as a tool. I'm not going to say we're selling the hammer again. I'm not going to say I want specifically lumber workers that nail in 2x4s using this size nail. I'm going to give you I'm going to give a demographic. If you're in that middle market of businesses I just identified and you're making a physical product, you're my ideal customer. I don't care if you're making prosthetics for someone. I don't care if you're making wild drones, electronics, antennas, whatever. If you fit into that, that's where you see most of the demand, and that's our ideal customer segment. It's a tool you can use it however you want. My ideal customer would come back to buy another tool in the future. I can tell you that much at least, but and expand those capabilities. But I'm not going to tell you I want someone to be specifically only printing this and buying it at this price point.
How much of your customers are repeat customers? Do you have a sense for that? Is it 10%? Is it too early to tell? Or?
It's quite a few because we do see a lot of that. So the one that I didn't identify is that 50,000 plus industrial market, which is where you see the automakers, the Fortune 500s, the militaries. A lot of them test the waters like, yeah, let's buy 3 to 5 machines. Let's feel it out. And then, okay, we want to buy 100. Or, oh, I'm doing custom bicycle helmets. I can either buy 5 your competition, but I'm trying to really manufacture these. Let me buy 100 of yours. So a lot of times we'll see someone test the waters and not even tell us. They'll say, yeah, I'm printing out this, I'm feeling out. They're like, yeah, we really want to manufacture this. We want to build that print farm and we want to be running off your machines because they worked out well. So in terms of what percentage quantity, because we've mostly been hit with the industrials, I think this is going to change as we start to saturate market a bit more and grow. Right now it's probably looking closer to 75, I guess. 3 and 4 tend to do so, but some of them are just smaller and they buy one and they're pretty happy. Others buy more and want to keep growing.
So is it fair to say that Creative 3D Technologies has the opportunity of making America a competitive place in manufacturing by replacing China labor?
I think so. Once we're at that single cell manufacturing tool that we were talking about, once we're able to bring that into proper market, yes. Until then, I think we're taking steps to that. I think we're really improving a lot of the manufacturing processes and pushing the barriers on what 3D printing can do. But I don't think it's a full replacement for a lot of things yet. But once that cost or final product starts to become competitive with China and you're getting more interesting results in shapes and geometries that they can never make, that's when the countries, well, that's when a lot of people saying let's bring the manufacturing back are going to get excited. But I'd almost hamper that excitement a bit because that power is going to be with everyone internationally. The same, say that headphone, that same file is going to be able to be printable and just as easily. And if you have power and as long as you have the material to do it, say you have a machine in your garage out here in Texas versus someone all the way in, like even say a third world country that just has power and just received a brick of material, and they could both make the same product. So I want to decentralize and distribute that power instead.
Yeah.
What is the availability to the customer of your machines? How much of their life do they operate? Do they suffer from breakdowns, outages, as all machines do? And what is the maintenance on them?
So we have one beater, we call it the beater machine, that we have been abusing for over 3 years at this point. We've had it outside in the Texas winter storm printing. We've poured caustic chemical on it. We've ripped power plugs from it. We've literally set fire to it in different instances, and it's still been running near 24/7. So I cannot give you a final upper limit yet because we're still pushing. So I can definitely tell you upwards of 3 years. We haven't found that breaking point yet, but as long as you do the most rudimentary maintenance, which the printer even tells you to. Usually if your printer is about to clog because it's been running a lot of material that's dirty, it'll start telling you, oh, it's about the clogger. So we're telling you, hey, you're probably gonna have a clog in about a month unless you start cleaning it now. Basic lubrication and maintenance like that, and we anticipate this being an over 5-year platform in terms of relevancy for capability, speed, precision, and that modularity of it. So we're hoping it can really help someone in the long term.
Johnny.
Yes, remember this, Ethan, the materials that you will utilize have not been created yet. Remember that as we think about the future and we think about material science, and they will probably come to you, and the printers will adjust and they will adjust to you. So we have lots of materials in material science now. But as the atoms move forward and we combine things, just remember that the materials that we use in your 3D printing has not been invented yet.
I've definitely seen it. We've seen some wild stuff like, hey, we outperformed this, what was deemed the highest grade of metal by like 400 times. Can your printer support this? I've definitely been seeing on the material science side evolving, and that's one of the reasons why I love having that platform be modular and ever evolving. As materials evolve, as people's needs evolve, let the machine evolve with you.
Sure. Llewellyn.
Well, I'm just wondering, what has been the total impact on manufacturing of 3D to this point in time? Is there data? Is 1/5 of our manufacturing already
know.
a 3D, or is it 2%, or is it 15, 20%?
Don't know.
A lot
I
of
don't think anybody
manufacturers
knows.
employ 3D.
Yeah, like I said, it's been a bigger shift for final products as of lately, and it's new to the industry that printing is becoming a method of making final products. That's not something that's been really employed yet, but it has really innovated on prototyping. And I did see a stat. I don't want to misreference it or misquote it because I don't have the number on the top of my head, but there has definitely been a massive impact on prototyping itself, and it's just starting to get that impact on final product manufacturing.
Yeah. Yeah, I think that, you know, it's a journey, but definitely modeling in engineering design and all that is where the bulk of it is today. In terms of printed things, anything that is plastic, you know, I was thinking to myself the first time I saw your machine, you know, I want to make the case for the iPhone, you know, so instead of having it made in China, right, I want to make it in your machine. Can I make it cheaper? That was my thought in my head. So.
But second of all, Andre, you should get a phone like this. That's a Samsung. Then all of a sudden, you know, it is you're behind. Show me that one screen phone. It's a disgrace to take them. So let's get
but this is an American product.
Huh? It's an American product. Huh? Well, open up your American car and everything is made somewhere else, but that's a different question for a different time.
Ethan, real quick, if you want to share, what's in front of you for the next 90 days?
Well, next 90 days are definitely a wild one for us. We have just opened up a bridge funding round because we have a lot of demand for a new product that we're launching this March. And so everything surrounding that new product launch in March is very exciting, but we're launching Duo Evo. So it's the evolution of our first 3D printer offering that had so much demand back in the day, launching in March, but we're also starting to get in people's hands starting February for pilot customers and people with really interesting applications, because with the market growing that quickly, a lot of people are buying their first printer across a lot of different industries. So if we can build a portfolio of renowned companies in all these different industries, like someone on the medical device side, so then we can make a case study about them saying, hey, look at what medical devices we can print, so that anyone moving in trying to do medical printing, for example, can see, oh, well, if they're able to make that part on this printer, they can probably make my device and help a lot of people connect those dots and do that across aerospace and everything else too.
Are there any incentives for using your technology? Are there any kind of government programs or anything like that for 3D printing at all?
I'm sure there are. I'm still trying to find them. I know the Biden administration actually just approved an additive manufacturing bill, but it seems like it's only going to a select 10 companies, unfortunately, instead of the ones that not as many people know about. But there are a lot of applications and there's a lot of grants that 3D printing are definitely partial solutions to. Like I saw one go by from the DoD about making more advanced wearables for soldiers, and they weren't asking for a way to make them, they're asking for the wearable. Someone designed something up, not manufactured in any other way, then using additive. It gets approved, it wins the contract, and then the technology never really sees the light of day because they don't know how to make it. So until the government asks the right question, asking for the kind of tech that we have, it might be a little bit, but we're pushing at it.
Tell me about your bridge round. How much are you looking for?
Sure, we're raising 1.5 million at the moment because we don't want to have people waiting come March saying, hey, you can order, but it might be about 12 weeks, and depending when you're buying, you're going to be further and further along on this wait list. So if we're able to place a larger inventory order closer into February, then that'll really help us out. So That's one of the main reasons, but just scaling the production, really making sure that we're ready for this growth, because look at it from a product standpoint. No one can compete with something that's 95% less expensive. You can't cut prices enough to do it. And no one's capable enough to really be a direct competition in a lot of areas that this printer supports, especially if we go towards a lot of the resolution, just how reliably this thing is built. Someone needs to innovate. Given that we're a lot of the R&D arm for a lot of these companies, I know exactly how long the innovation cycle is, and there's a lot of really custom tools and processes and things that need to be developed that we keep trade secret that are necessary to making this function. It's going to be a 2-year maybe cycle for us to make a competition. So as that market's growing, we're relevant to more than 60% of it. It's growing at 30%. We'll have an opportunity to corner a lot of that market. And as long as you scale as fast as you can gain that market share.
If anybody listening to this wants to get a hold of Ethan, just ping me. And if you want to be part of that 1.5 million, real quick, guys, the top 10 things for 3D printing that are selling. And I would imagine, Ethan, the Etsy and Amazon at some point are going to have a creative 3D printing farm of printers doing stuff, but miniatures, and obviously costly items like, the collectible things, Darth Vader helmet, things like that, jewelry, toys, and these are all the things that Ethan's product does. Nerf guns, accessories is a big one. Architecture models is another one. Figurines and statues. Phone cases.
Actually, 3D printers haven't been able to do architectural models, because architectural models, building models tend to be pretty big.
Yeah.
The big printers haven't been precise enough to do it. So we're one of the first printers that could really do, like, you want a 3-foot wide architectural model that's like 2-something foot high, and you want all the details on the bricks and the trees. Good luck finding a printer that can do that.
Yeah. Number 9, self-watering planters. And then the last one is designer vases. I think I'm going to go into the designer vases, Butler. We should do a designer vase.
Well, when you can design a genetic fish, you call me.
Well, we have someone using it for bioprinting. I'm not entirely sure what they're making, because I don't understand it, quite frankly. Yeah. But they told us, this is precise and fast enough to do what we want. It's a lot cheaper than anything else, platform wise. Can we throw syringes on this thing and throw petri dishes on it and experiment with printing human organs?
I think I want to get into. I think I want to get into the eyeglass business. I want to do frames.
We have a couple of glasses brands starting to buy them as well, so that's a good one too.
Yep.
Anyway, but parting thoughts, gentlemen.
I'd like to know what your business structure is. Is it privately held? Are you planning to go public? What is your structure?
Currently private. We're hoping, as we scale and hopefully become an industry leader, that would put us in a pretty out place to go IPO. So eventually, but we're building to that for a while, and until it's necessary, we're going to take our time and give the absolute best.
Question: do you have direct competition?
We have competitors for each individual function, but there has yet to be anyone that's approaching 3D printing from the all-in-one suite, because when you don't need to directly compete, when you don't need to innovate, if you can get away with overly high margins, have a nice looking box that uses the same cheap Chinese parts on the inside, and no one else is selling at that price point, so customers are dependent on you, there's not much need for anyone to make something like this when it's such an engineering nightmare to do. So direct competition, no, but I'm happy to cite any individual competitors, like, the next quickest printer is this printer, the next largest printer is this one, and we have individual function competitors, but not all in one.
So the way to think about it, they are the Microsoft Office of printing, and you could have your WordPerfect and your Harvard Graphics and your Lotus 1, 2, 3, but we know who won in the end.
It's called Microsoft.
Exactly.
Yeah.
So parting thoughts, guys?
Just don't sell yourself short on what 3D printing would do in the future, because the machines will get smaller and the materials will change. And then we'll get larger to print houses out, and it'll be all over construction, and we'll be 3D printing skyscrapers downtown by the time you're my age.
Oh, yeah, I'm excited to see it.
Yeah.
Llewellyn?
As a general view, often the technology finds a mission other than the one that its creators had it in mind for.
Yeah, I think that 3D printing with digital twinning and digitalization in general has no limit, has no ceiling. The sky is the limit. I was thinking that actually, Ethan, we should work on a version of the machine that makes watches and take Rolex out of business.
Well,
Hey,
you know,
we can print in gold and we can print really fine details. Some folks are already doing jewelry, so I don't see why we can't do a watch.
but you know, it's against the law to say that you're going to put somebody out of business, so I won't comment on that.
Yeah, don't put me into that we. I'll give you the tool. You do what you want with it. I keep the door shut. Keep
Don't
my
mess
eyes
around with
closed.
By the way, Rolex is a private company. It's a family owned, and they don't care if they can't meet the demand. Very interesting.
Yeah.
Okay.
Ethan, thank you for being with us today. You're always, beyond expectations, and congratulations on everything. And I'll circle back on that bridge round that you're putting together.
You betcha.
Sure. Appreciate the opportunity.
All right, guys, take us away, Johnny.
Merry Christmas.
Have
Merry Christmas.
yourself a merry little Christmas. May your heart be light. From now on, your troubles will be out of sight. And have yourself a merry little Christmas. Make the Yuletide gay. From now on, your troubles will be miles away. Here we are, as in golden years, the happy golden years of war. Faithful friends who are dear to us, gather near to us once more. Through the years, how we'll be together if the fates allow. Hang a shining star upon your highest bough, and have yourself a merry little Christmas. Have yourself a merry little Christmas now.
Merry Christmas and Happy New Year, everybody. Thank you
Can't
for
3D
everything.
that baby.
Thank you,
Can't
Ethan.
3D that baby. Okay. Take care. Bye-bye.